Everybody, today we are discussing the next topic, that is single electron transfer mechanism. In the last class we have discussed SN1 reaction, SN2 reaction, SNI reaction, neighboring group participation, and now we are studying SCT mechanism, single electron transfer mechanism. So in some nucleophilic substitution reaction, SN1 is not possible. In that case, some rare case, we can see that the radical is generated in the reaction medium, and that radical can be detected by ESR spectra. And this radical is generated as the intermediate, and this radical combined together and to form the final product. So here the nucleophile is added as a radical, and the starting material, the radical is combined with the radical. You know that the radical is highly unstable, so it will combine each other and to form the stable final product. So here the nucleophilic substitution reaction undergo through the radical which is generated in the reaction system. And usually carbocation is a good electron acceptor and the nucleophile is a good electron donor. So in the mechanism, we can see that an internally a nucleophile is generated, and that nucleophile is added in the radical starting material. See the example. In the reaction between the triphenyl methyl cation and tertiary butoxide ion, the tertiary butoxide ion first of all donate one electron to the carbocation. So the carbocation accepts this electron and become a radical. Similarly, tertiary butoxide anion become a radical. So now we have two radical, pH3C radical and tertiary butoxide radical, and radicals are highly unstable, and here the tertiary butoxide is acting as a radical as a nucleophile, and pH3C radical is acting as a starting material. So it readily combine together and to form the tertiary butoxide Bu of CpH3 thrice. Okay. Now, and how the pH3C plus is generated? Carbocation, we know that the carbocation is generated by the liberation of the leaving group. Okay. So usually carbocation is formed in the SN1 reaction. Here this is not an SN1 reaction. So in SN1 reaction, carbocation is normally generated by the liberation of the leaving group. And here also the leaving group is liberated and carbocation is formed. Then the reaction proceeds through the radical mechanism. Now we are moving into the next topic, that is nucleophilic substitution reaction at allylic carbon atom. So allylic carbon atom, in general structure, the allylic carbon atom, there is a two type of the hybridization exist in the allylic alkyl halide. First one is sp3 hybridized carbon atom and second one is sp2 hybridized carbon atom. See here in this example, the halogen atom, that is 1, is directly connected to the carbon atom at 2, and here the 2 is exist in the sp2 hybridized, sp3 hybridized, and 3 and 4 exist in the sp2 hybridized. So the sp2 hybridized carbon atom is connected to sp3 carbon atom, then X. So in allylic substitution reaction, first of all, allylic substitution reaction undergo both SN1 and SN2 and usually accompanied by certain kind of rearrangement in SN1 reaction. This is because in SN1 reaction we know that the first step is generation of the carbocation. So usually the carbocation is generated in allylic halide also, but the allylic carbocation is a primary carbocation. Okay, see here this is a primary carbocation, that's why it readily undergo the rearrangement and to form a secondary carbocation. Then nucleophile can attack equally to both the carbocation, that is primary and secondary, and we will get the two product, that is product A and B. But the position of the nucleophile in A is different from B. In A, nucleophile is in the terminal position, and B, it is in the branched position. So this is mainly due to in nucleophile, in product A, nucleophile are attacking in the second position, and in the product B, nucleophile attack in the fourth position. So the two product is formed in the SN1 reaction. This is mainly due to the rearrangement occurs in allylic carbocation. So the box which is shown in the yellow color shows the rearrangement of the allyl alkyl halide. Now we are moving into allylic nucleophilic substitution reaction in SN2. In SN2 reaction, we can see that only one single product is obtained for the allyl alkyl halide, and the configuration is also inverted because the leaving group, the nucleophile approaches the reaction site in the opposite direction of the movement of the leaving group. That's why we will get an inverted configuration for SN2 reaction, and only one product is obtained for the SN2 reaction. And one more thing, in SN1 reaction, we will get an addition in the 1,2 position, and whereas in the next case, we will get the nucleophile is attack on the 4th position. So both the addition is in substitution is possible in SN1 reaction. Thank you.